of enum, how to use enums, enumerations, and about enums. Now, generally, how we can configure and yes, yeah, fine, right, okay. Now, how we can work with the enums, how we can deal with the enums. Actually, as I already told you, better to use enums as types. Always use enum as a type, not as a collection. Actually, it is always important to use as type. So, for example, I just given here. So, enum, and you are defining some points like logs is an enum, and here we are defining error log, and we have an warning log. So warning log, we have a info log, we have a debug logs. Such logs are there. Now, technically, when you are creating one type, generally, so we can handle various categories of options, right? So these are general console related log options available here. Now, usually we want to create one type. Just we want to create a data type. So, and these data types should support several types. One type should support several types. So in that case, generally, there are several techniques to define. There are various techniques to define. That means, in general, I'm telling this, I will just come back to this point actually. Suppose here I'm defining a string. Here I'm defining a number. Here I'm defining some boolean like this. And I created some multiple, and here it is of type logs. Actually, so what does this represents in generally? Actually, what does this represents? So this represents that now this multiple is of these types. That means it can be a string, it can be a number, or it can be a boolean. It is simply like, so you are configuring simply like you are configuring a simple variable. At this variable is having the type as string, and it is having the type as number, and it is having the type as boolean, like this. That means a certain type of constants are configured. Then it can use those constants and it can handle those constants. It can use and handle those constants. So that means now instead of defining so many types, you can configure it as a type. Instead of defining the types, you can configure as a type. Just configure as a type. So that means one enum type can handle different types of values or the same type of values. So that means with one reference, you can designate that it can be any of these types. Any of these types. It is equivalent to that. In the libraries, when we build the libraries, actually the libraries are built in the same way, in the similar way, so that we can configure strictly typed. We can configure strictly typed. So that is one approach actually. So a set of types can be defined as an enum, and that enum can be used as types for that particular reference. That is the intention actually. So that it should be of that particular type. It cannot be any another type. It cannot be any another type. That means, for example, here I defined this is just an concept I am explaining. So means strictly typed, how we can make it strictly typed. Suppose we are defining an enum. I'm mentioning size is an enum. Size enum is having height one property, and width is one property. Height and width is one property. These are the two properties we are having. And I'm creating an interface. And I name this as suppose table. Table is an interface. Okay, this table interface is having some properties. So it is having some properties. So like I have a vertical is one property, and this vertical property is of type size. From size it is of type height. That is a vertical property, so it is of type that. And I am defining here that is horizontal. So horizontal. So or we defined the vertical is height, and here another option is configured. Some other option is configured. That means suppose color. So color is some string type. So that is the type. Vertical is of type height type, and this is of string type. Okay. Now we are creating another interface. And this is a simple like div, suppose. Just basically I'm giving. And this div is having a width. So that means horizontal. Or this is also having a vertical. So vertical or horizontal options we have configured for this. Now vertical is of type. This is also of type height. It is of also type size height. we are defining. So the point is we are configuring a specific type vertical, and for suppose div vertical, or say generally we have v align, a align like options. All right. So here for div we have vertical. So here height and width. Suppose here I will add one more is v size. So this is vertical size, and here we are using vertical size dot v size. That means for table vertically you can give height, but div we cannot give vertically height. We will give v size. That is the property type defined here. The property type defined here. So in that case, what happens is that is the height process we have configured. I'm not defining any width. For height, only two options are there. One is height, another one is v size. Now I'm creating an object. So let, I'm creating an object for table, emp table. Okay. This emp table is of type table. And for table, we are giving the option. For table, we are defining the option that is vertical. So that means vertical, we are applying some value. So we are applying the vertical value. That means we are configuring some value. So for table here, emp table vertical, we are trying to apply this v size property. That means from the enum, from the size enum, we are trying to apply the v size property. So that means here we are accessing size. From the size for emp table, I am trying to apply the v size here. From the size, we are configuring the v size. That means we just define the table. We can add some value into it. That means this is a table equal to, we are adding some value, and the size I am applying here in the size enum. Two are there, height and v size are there. Now tell me, for employee table, which one I can apply? Is it height or v size? Which one I can apply for employee table? Employee table is implementing which interface? Employee table is implementing which interface? Which interface employee table is doing? Can you tell me which interface it is using? Table interface. It is using table interface. Okay, good. That means now employee table is using table interface. Table interface is having a vertical property. To that vertical property, what is the data type specified? Table vertical property, what is the data type specified? The data type specified is height. So whenever, but enum size is having both height and v size na. Enum is having both size and enum. But for table, you cannot apply. Generally, you cannot apply v size. Suppose I am trying here size dot v size. I am applying v size. I am configuring v size. Then obviously it will get a problem. It says that so vertical. So v size is not applicable for this. But v size is already a member of size property. Size enum. Size is having v size. But why I cannot apply v size for employee table? Because it is table type. In table type, vertical means only it can handle height, it cannot handle v size. That means this is invalid. Suppose color, I am defining color is a string type, I am defining some red, that is some value I have configured. You cannot apply this. For vertical, you can define height. You can define height. Suppose I am applying here size dot height. That is okay. That is okay. That means generally what happens is across different types of objects, same property may be used, but with different values we use. For example, if you know HTML, I think many of you know that image have width. Here when you mention the width, you will mention 400. That is number. So 400 number. But for image, when I am applying width through style also have width. But here we have to define 400. Is it valid? Is it valid? What do you say? Is it valid? It is not valid actually in CSS. It is not valid because it is expecting units. Units means pixels. Understood? Understood? That means same property is there. In two occasions we have to use them. But one time it should handle in one way. Another time it should handle in another way. That means we need one collection of types which can be used for different objects for different situations. Understood the point? That means we need to configure one which can handle for different. Width is same, but here you mentioned only number. Here you mention a string with pixels specification. So that means here it will not allow you to define the v size for div. So for div we are using here. For div we are configuring. So that means let now div. Okay. And it is a div type. So it is a div type. It is implementing div type. And it should implement vertical. Here I can define size. I cannot apply height for this. Height is not applicable. For this we have to apply only v size. We have to define v size. We have to configure that v size. That means what value it will return depends on what value you want to initialize into it. Because it is an enum value, you can initialize any value into it. Here enums are used mostly for not just collection of some constant values. Enums are mostly used for collection of some constant types. It is used for collection of some constant types. So in this example, this is an example for enum. If the table is trying to use so v size. So this will be invalid. It cannot have it. Right? That means it should have vertical and size. It should be height. Then it is valid. Similarly, here this is valid. And if I define, so here vertical for div and size dot height, I cannot use this for this because it is a div type and it cannot handle the other types. So we have collection of types, and it is not necessary that these all types must be used every time. You can access those types and use those types for different situations. you can configure the types and you can use them for different situations. For one situation, one type, another situation, another type, so that it can handle only that particular type of values. So this is very much required in the background of building up libraries and using the libraries. When we are creating and working with libraries, we need this type of approach to follow. So mostly enums are used as types rather than used as collections, rather than using as collections. So that is what actually the intention is, right? So generally, how we can configure enums that we discussed in the last session. But where to use the enums? What is the situation for enums? It comes in different occasions. This is one occasion I told you. So later in our examples, we will come across with various occasions. We will see them, right? And different situations means majority it will be like we are working on libraries, building the libraries. When we are designing and building the libraries, then we use this approach very much, right? In general uses, you directly use enums for building the libraries, constructing a new types, configuring and restricting the types for them. These are all the important points, right? So you need to know the situation. That means all the types are configured at one place, and we can assign different types so that different element can handle those types from coming from the same collection. So this is generally concept of enum, how we can configure and work with enum types. Several other examples I will show you in different points we will discuss also. So means in our examples of Angular we can handle that, right? Next important, after understanding the enum and its configurations, we need to know about modules in TypeScript, how we can configure and use the modules in TypeScript. So another important is understanding about the TypeScript, right? Now the point is, what is module and what is the intention of modules, right? So let's see what is the concept of modules. Actually, in early versions of JavaScript, we don't have modules. JavaScript introduced modules in ECMA 2.15. So actual modules introduced into JavaScript. Modules introduced into JavaScript with ECMA script 2.15 actually. So from ECMA script 2.15, right? Now important is technically what is the module, and it is introduced, and TypeScript uses modules of JavaScript. TypeScript uses the modules of JavaScript. TypeScript shares this concept. So now important, technically what is a module and what is its purpose and how do we use this modular purpose, right? So let's see. Actually, technical points about module you need to understand here is modules. We can simply say that it is like a module. Module is like a component. Is like a component. A module is like a component in any framework. Module is a component in any framework with the collection. with collection of various other various with collection of various members. So module is like a component in any framework with collection of various members. So you can import modules from external sources, and you can import modules from external sources and use in your application. So a module contains a set of functionalities. We can use them actually. uh, modules are executed within their own scope, so not in the global scope. Generally global scope, not in the global scope. So that means the variables, functions, classes, all are declared in a module, and they are not accessible outside, and they are not accessible outside. Now, to make them accessible outside, you have to mark them with export. We have to mark them with export. In order to access outside, you have to mark them as export. I told you module is what here you can see is like a component in any framework with a collection of members like variables, classes, data type, functions. That means module is a collection of members inside it. And as I told you in the definition, like you can import into any application, which means that it is a library. Am I right? We can import this into any application and we can use that. That means it is like a library. So it is just like a library, configured like a library, defined like a library, so that you can use across any location in your application. And important is, physically you will not use any module like keyword. You will not use any module like keyword. It's a library which you can import and use in any application. So how it works, I will show you, then you can understand that, right? So technically, if you want to import, you can import by using import reference. By using the import reference, you can import a module. You can import any module. By using import reference. By using the import reference. That is the intention. Of the module. That is the key point about the module. I will show you where we use, how we use. Our Angular completely depends on this modular approach. This is modular approach. And actually JavaScript requires AMD, that is asynchronous module distribution, AMD, and common JS like systems. So to handle modules, modules. But TypeScript can implicitly handle modules. Implicitly can handle modules. JavaScript cannot directly handle them. It needs an additional systems. It needs additional systems, right? We need additional systems like CommonJS, AMD, asynchronous module distribution systems. We need that. Now, how it works, we will see one simple example. We will see, right? Now, there are so many keywords and points to understand. Step by step, I will explain here how we can configure the modules, import the modules, and use the modules. Let's create one simple scenario here, means library. So I'm creating a new folder here. I'm creating a library folder. I'm creating a library folder. Okay. So this is the library folder. In the library folder, I am maintaining some subfolders. One is contracts. Contracts is one folder. Okay. In the library, I will maintain another folder. Templates. Templates is another folder. And in the library, another folder. Components. Components is another folder. Okay. Library contains. So library contains components, contracts, and templates. Okay. Let's go to contracts. What is the order? The order is we start from designing contracts. I will create here a simple contract. We will configure one contract here. So let's create one contract and configure a contract. Let's see. So add a new file and I am configuring a contract here. I will just contract.ts. So we will configure a simple contract. That means contract, you know that it is an interface. We will create a contract here. So let's see. So that means what we are doing, we are creating an interface and I will give a name for that interface. Right, I will create a configuration for that interface. So that is iProduct. iProduct, that is product.ts, that is iProduct is an interface. Its name is product contract, file name. And in that we have that iProduct. And here we are defining some properties. Name is a string type. Okay, price is a number type. Price is a number type. And we have quantity. So some number type. Okay. And total is a number type. And print is a void type. Yeah, these are all the options in the contract. We are configuring all these in the contract. Okay. Now this is the contract which contains the rules for designing any component. And it is kept in this module. Now this is a module. This file is a module. TypeScript treats this as a module. It treats this as a module. This file is a module. A module can contain several interfaces inside it. Now, this file is a module and anything defined in this file is accessible only inside it. It is not accessible outside. Then we have to mark this as export. We have to mark this as export. Then only you can access it outside this module scope. It makes it global now. Otherwise, it is accessible only within the location. Within the location. So our contract is ready. Okay. Now let's go to our library. In the library, we will create a template. So directly, we will not implement contracts in our classes. So we generally create a template because template contains some implemented, some need to be implemented functionalities, right? We need to roll out these templates. I'm going to template and I'm creating a new file. This is product template.ts. In the product template, I want to create a template. How you design a template? So template means it is an abstract class. Abstract class. It is an abstract class. And I will give the name as product template. You can give any name. Product template is the abstract class. Okay. Now this abstract class should implement that contract. That we defined. So contract is present in a module, separate module. You cannot directly access that here. That means if you try to directly access, it implements iProduct. What is the specialty for your Visual Studio is it will identify in which module this is present and it will import that module automatically for you. Actually, we need to manually import it. As of now, it shows an error because there is no iProduct here in this module. Then first what we have to do is we have to import that module here. How to import? By using the keyword import. Import and in the flower brace. So import from. So what to import? You have to mention in the flower brace. From which location? You have to mention the path. So you are currently in templates folder. You have to come out of templates folder and go to contracts folder. How to come out? Current folder /. It comes off current folder. And in that we have contracts folder. In the contracts folder, we need product contract. Only the contract name, that means module name. File name is used as module name. Okay. In that module, there is an interface. We can access this interface. After importing the module, you have to import the library of that particular module. That means the interface we need to import iProduct from that particular contract. You can import multiple by using comma. You can import all by using wildcards. That means generally people use asterisk. Import asterisk doesn't require any flower brace actually. We don't need any flower brace, right? We can directly use star. Directly we can import everything from there. Flower brace is just to define the scope, right? That means I want only iProduct. Okay. Now this product template can implement iProduct. In that case, it has to define functionality for all of them. Whatever rules are there inside it, it has to define all of them. But template means everything is not defined. So what I am doing, public, so name, string. I am giving an access specified for that and it is empty. Fine. So next is public price and this is number and I will put some initializing 0 and public quantity and this is also number. I will implement with 1. that is the default, and public total, total is a number type, and here total also implemented, return this dot quantity into this dot price. Okay, and public print, print is an void, but I don't want to implement its functionality here. Then if you don't want to implement the functionality for this method here, because it is a template, you need to roll out and print with a different requirement, then we need to mark it as abstract. That means an abstract method must be marked with abstract. That means it is an incomplete method. So that means it requires implementation in the next level. So this is actually the component. Okay, that means we have created a template, and in the template we implemented the rules. But template means it contains some incomplete which need to be implemented later. But again, this template is in a module. This module is not accessible outside. Then I need to mark this also as export. It is marked as export. That means now you can access it outside this module scope. So this is a template. Template is also ready, and it is having a clean separation now. All your contracts are at one place in a separate module, and everything here in the module. Now we have another option. We have contracts, we have templates, and generally I will give the name for this reasonably as services. Now services will implement all the functionality and define all the functionality. You can give any name, doesn't matter. That means now here I will add a new file, that is product service .ts. This product service should take the template and implement all the functionality of that particular template. Then usually what we need to do here is we need to just configure. Simple. So first import. What you need to import? So I need to import from. So import from. Yeah. From where you want to import // from templates, I need to import a product template. In the product template, we have an abstract class called product template. Okay, this we need to roll out here with our own functionality. Then I am defining export class. It is an ordinary class now. This class is a product class, and usually product class implements the template or extends the template. Tell me, product class implements the template or extends the template? What should be the correct one here? So it should extend the template. Am I right? It should extend the template, right? That's good. Okay. So that means it should extend the template. So it extends product template. It extends the product template. Okay. Then obviously this has to define the functionalities. All the functionalities should be defined here, and you can access them through super keyword. You can access all of them, and here we can just add the additional functionality here. What is that? So public, and it has to use a print function. So it has to use a print function, and print is an void type. And here we need to implement console.log, and I need to get the values and use the values here. That means here you can initialize them, or you can use with the specific properties and values. You can configure. And how we can access and use that here? Suppose, so console.log, it needs to print them, print the values, configure the values. That means here we can create configuration for them. Generally, how we can create, what do you say? Suppose I want to print the name. Then I can access directly name as a super dot name property. Is it okay? That means it is accessing from the base class. What do you say? Is it okay? Accessing the super. Directly you are accessing that super. Right. Already we learned that in OOP concepts, what is difference between extending and implementing. I told you while working with contracts, extending and implementing, right? We discussed the difference actually, right? In OOPS, we have learned almost one day we spent on this extending and implementing and all. Right. So here the point is, already we know what is extending, what is implementing, right? We already discussed so many times. So generally, you others, if you have the point, tell me what is the difference between implement and extends. What is difference between implements and extends, and in which situation we have to use implements, and which situation we have to use extends. Actually, we have to use implements for defining rules for designing a component. Am I right? Implements is for defining rules for designing a component. Rules for designing a component. If you are defining the rules for designing a component, the rules are implemented. The rules are implemented. And functionality is extended. Rules are implemented and functionality is extended. So template is implementing, template is implementing contract. That means it is implementing rules. And this product class is not implementing the template, it is extending the template. That means implementing rules are implemented and functionality is extended. If you are extending the functionality, then extend. You are just using the rules, then you have to use implement. Now here, if I try super.name directly, right? Actually, you can, because it is a rollout, we can completely configure them again. Or here we can access them and use them here. So that means, suppose we are accessing super.name. And in the next line, I'm defining some price is equal to dollar super dot price. And here another, we have a quantity is equal to, so dollar super dot quantity. And here we have another total is equal to dollar super dot total. Total is a method which will return the total, right? Which will configure and return the total here. That's what we extended here. The functionality is extended here. Already the functionality is defined. Here we are extending that functionality. Some more additional functionality we are configuring here. Right. You can redefine everything. We can redefine everything, configure and redefine everything. So this is one point. Now here some issues will come if you are directly importing that names. I will show you that. That means now finally contracts are ready, templates are ready, and services are ready. You just inject this service into your application and use it. You have to just inject this service into your application. That means I will create a new folder called my app. Okay, in this my app I will create, so here, a file simply like home.ts. Okay, in this home.ts I have to implement that functionality. Then I need to import the service here. I need to import the service here. So service from which location? Import from. I need to import the service from dot dot. Actually, it is directly outside, right? I need to import from library. So I need to import from library. From library, I have to go to services. In the services, product service. Okay, and we need to inject that product service. Configure this product service here. That means we have to use product class. Product is the class, so which is of type product service. So better we will give the name as product service. Product service extends the products template. It extends the template. You don't know why to use dot dot. It is general HTML thing, na? Not HTML. This is general operating system. In operating system, Windows or anywhere, how you will come out of the current directory? Single dot for current directory. Dot dot to exit the current directory. To access anything present in the same directory, we use dot. To come out of the current directory, we use dot dot. You don't even know that, Kundan? These are general path references actually, right? Even you don't know, no worry. So at least now understood, dot dot means come out of the current directory. After coming out of the current directory, we have to access library. In the library, we have to access this. Understood? Right. Now in that we have a product service. Yeah. Now in this product service, we are configuring. So here we are configuring a class. So we can import directly the members and use the members here. We can create a class or we can directly configure here. That means I'm creating a class here. Class. The class is product. This product class have a constructor. It is having a constructor. Into the constructor, we will create a private service object, and it is of type product service. It is of type product service. So it is of type product service. That means whenever the class object is created, it loads this service and it will work only for this class because it is private. Am I right? It works only for this class. Now what we can do is, that means this service is of type product service. Now what you can do is the members of that service you can access from here. That means this is actually, suppose we say data. Data is of type product service. You can access the data here. So what you can do is we can create, means it's a reference. So you can access like this dot. So we create one method here, print method. And in the method, we can access this dot data. Data dot, you can access all the members from there. You can access all the members here. So we can configure and access the details. There are several approaches. You can use any. But this is how traditionally we follow. Generally, you don't need all this. I will show you two different examples. Generally, you don't need all this. Generally, what you can do directly, you create an object TV. This TV, so is of what type? Is equal to new product service type. So that means it is of what type? So what is the class name here? Product service class. That means it is of type product service. It is of product service type. You created an object for the product service type, right? So generally, when we are defining, so that is service type. Then through TV, we can access the details. So name is some name, Samsung TV, like this. So TV dot price, so some price, and so TV, so say quantity, some quantity we configured, and TV dot print, we have printed the details, and we need to compile and run this. We need to configure, compile, and run this. Now, one issue is there here. The issue is you are directly using the superclass members. In a print method, you are directly using the superclass methods, printing them in a service actually. Generally, a service requires complete implementation of the functionality. Now we will run this. Which one we have to run? Home, we have to run. Actually, JavaScript cannot directly run. Usually, in order to run, JavaScript have to use AMD systems, common JS systems, because it is present in several files. If I compile only this file and run this file, then what will happen? It will generate only this code translation. But TypeScript have the ability to extract all the dependencies and compile them. That's great. JavaScript don't have that. You have to again combine all the files and compile them. Here we don't need to do that. You just finally run the final one, right? That means here open this app, and here we are configuring. So TSC, so that is home.ts. We are configuring home.ts. It will extract and it will generate. It is showing some errors. Error is related to this super issue. I told you already. And I'm compiling this now. So that means I'm running this. So that is home.js. I'm executing that. So it is not having anything. So why? Because actually the template approach, usually the template approach, how we need to design the templates, that is the key point here. The template approach, you are trying to access this super. Already I told you this. We are trying to access directly this super from an incomplete class. A template, you are accessing it. So it is always recommended, don't directly handle through a template. It is always an issue. Then what is recommended always here? You have to roll out everything. That means we have to use a public, so name, and it is a string type. It is a string type. Currently it is empty, nothing is defined. Another public, so price, it is a number type. You configured that, that is 0. And public QTY, quantity, this is also number, and this is also empty. And public total is a function, So that means it should return a number. So here how we defined that total as a number, then it should return a number. So this dot quantity into this dot price, and you have to use here directly this. From a template, you never attempt to access the members and use until or unless it is a complete, having a complete functionality. Otherwise, this will be an issue for building a library. That means here we have to define this dot quantity and this dot total. And finally, this is extending with one more functionality here, configured here. Now I will compile this here. So tsc home.ts. Then you will avoid those issues here. So price is also there. I need to check that price is also changed. That means this dot price. Okay. Now I will compile this here, and you can see that now it is compiled successfully, no problem. Then home.js, observe carefully, home.js is working, so it has to display all the details. Now here to display the details, we have to print the details, right? That means console.log is printing all these details, and that is already configured there. Now here, what we need to do is in the home, we need to access that print. We need to configure those details. So here to configure the details, first we need to access the details. This is a product service type. This is a product service type. And in the product service type, we are creating an object. We are creating an object for that product service. So that means from the services, it is importing the product service. Generally, when you are defining the service, so you can see that it is an alias of product service type. It is an alias of product service type. So because this name have a problem now, because the product service you are trying to implement, it is matching with the library that you have already configured there. So let's keep this as a product type. So we keep this as a product type. This is a product class. And in the home, we have to import the product class. And here we need to create an object for that product class. And through that object, we are accessing these details. Through that object, we are accessing these details. And this print method should print all the details, configure and print all the details. So let's compile this here. So I will just compile that. And once it is compiled, go to the TS file and see, JavaScript file and see home.js. You can see it is using a strict mode. It is using a strict mode. And observe carefully, because it is having a lot of strongly typed contents. And you can see it is using a require method to import your library. That is how generally JavaScript does. JavaScript uses a require function. So by using this require function, it imports the library. After importing the library, it is creating an object for that particular service. So from that, it is importing and it is configuring and it is accessing the values. Now this print method have to print the details. That means it is internally using a modular approach. So, and it is configuring the modules. This is not possible directly in JavaScript. Actually, directly JavaScript requires additional modular systems to handle. Through the modular systems, you have to compile all the files and configure all the files. So now here I am writing here node home.js, and I'm accessing this, and it has to get the details and print the details. So this is the basic approach, how we can use the modules, configuring the modules, handling the modules, and using the modules. So there is another alternative technique. We can use a namespace mechanism, but JavaScript based environments always prefer this modular system. Namespace is used by Microsoft people. Because TypeScript belongs to Microsoft, it will allow you to configure a namespace mechanism. But in Angular, you will see majority of this concept only. In Angular, you will see majority of this approach only, right? So that's the reason you should know this process, how we can create modules and configure the modules, right? So this is one basic example that we created. I will show you some more points and some more examples about modules and working with modules tomorrow. Then tomorrow, one more option we will discuss about service namespace. Then we can conclude this TypeScript. Then we can go into other options. Right. Everything is a design pattern. Actually, we call singleton design patterns. So abstract factory design patterns. There are so many patterns implemented here actually. So generally services are used with a pattern called singleton. We are not physically implementing it. We have to implement in that way. Right? By default, it is using abstract factories. So by default, it is using so many types of approaches here. So you are not practically configuring any pattern here. It is already using those patterns implicitly, right? Yeah. Then tomorrow we can continue. Sorry. When we finish home.js, already I showed you how JavaScript calls the modules. To show you that, I showed you home.js. How JavaScript calls the modules directly. Generally, JavaScript will not use import and export terms. Actually, it uses this mechanism of require. If you have learned any JavaScript based technologies like Node.js or others, so this is the approach how you import libraries actually. Huh? That is the intention to show. Huh? Every day we are sending the code for practice. Na? Now, that is just to run in an application and see what it is generating. That is not required at all. You have to run Node.js. Na? Right. If you are directly typing that, that means you are trying to open in application and view it. Huh? To see what is there inside it. But we can directly open in Visual Studio and see. Na? Right. CommonJS, AMD, asynchronous modular techniques actually these are. That means compiling the modules, loading the modules, importing, exporting the modules from multiple modules, generating an application, all this is managed by them. Okay, fine. Let's meet tomorrow then. Right. Yes, Vijender, what is your